this presentation is focusing on the application of Open RAN in terms of education. So meaning we are providing connectivity with university or campus or to whatever institutions that they would like to have connectivity in their infrastructures. So just imagine a school where every student can access the high speed na internet, and then they can also stream educational videos without buffering and engage in interactive online learning without a hitch. So this is possible, especially in the current case right now. If a university is connected via Wi-Fi and also via a traditional radio access network, and it is also possible with the use of Open RAN. So in this discussion, we'll have some checklist or assessment on how do we dimension or how do we evaluate the necessity of having an Open RAN connection in a university or campus. So let's break it down step by step. So I prepared some topics for you. So first, we'll understand what is Open RAN. So I believe most of you already knows what is Open RAN, but we'll have some review about this. So we'll compare it with the traditional RAN and what is the different advantages and challenges. And then we'll discuss some assessment and requirement gathering that we need before deploying an Open RAN in your university or campuses. And it also includes site survey and infrastructure assessment, and then coverage planning, capacity planning, hardware and technology selection, and then we go to implementation, testing, and optimization, and goes to monitoring and maintenance. Although the topics seems like a lot, but it only has around a few slides. No, okay. So let's start with the understanding of Open RAN. So what is Open RAN? So when you compare the Open RAN with the traditional RAN, so traditional RAN solutions, they're saying it's monolithic. So meaning it's a one vendor approach, and it's based on a specialized hardware. And then vendors provided limited control to configure the RAN products via proprietary OEM interface. So there was a limited availability, no, when you're using the traditional RAN coming from the traditional RAN suppliers. And it was very difficult for new vendors to provide an innovative solutions because the RAN products were monolithic and proprietary, as I mentioned. And it was difficult to introduce new feature unless it is already in their roadmap, in the vendor's roadmap. So it was hard for operators and independent software developers to gain control over the RAN equipment due to proprietary interfaces and licensing restrictions to build new features. And now comparing with the Open RAN, so when we transition from traditional RAN to Open RAN, so we will have a standardized software-centric approach based on commoditized hardware, especially the commercial off-the-shelf servers. Okay, and it will also enable us to mix and match different hardwares and softwares uh, to implement the radio access network. And to implement this mix and matching, an open standard interface will be there to ensure the deployment of multi-vendor between the radio unit and the CUDU ecosystem. Okay. So there are benefits of using Open RAN. So first, we have a diverse vendor ecosystem. So this will remove the vendor lock-in as we see in deployment of traditional RAN. So it will have a faster network deployments due to automation, okay, and the centralized radio architecture. And then there is also what we call the new innovation model introduction. So uh, in this innovation model, it will make a more accessible third-party software developers, and it will also running on automation models and data-driven based on artificial intelligence and machine learning. And then, of course, in the long run, we're looking at a lower total cost of ownership. So this is due to the use of white box concept for radio unit, commercial off-the-shelf servers, and continuous integration and continuous deployment approach in testing and validation. So the factors that will affect the lower total cost is the reduced time to market and reduced time of deployment, and of course the equipment maintenance costs. Although in the aside from the benefits, so there are also challenges when deploying Open Run. Number one is network performance. So this is a common concern regarding the Open Run, which is the ability to match the performance of the proprietary hardware platforms. But in the recent lab trials and live deployments that we see in, like, for example, Dish in the US and Rakuten in Japan, um, this concern or challenge were already addressed, and there are proof that Open Run is meeting performance objectives. Next is the fault management. So when something goes wrong in the network, isolating the component that is the source of the problem can be more complex in an Open Run environment. So to solve this challenge, the network management tools have been deployed for Open Run that is contributing to root cause analysis and speedy issue of resolution. Next, the network automation. So to fully realize the benefits of Open Run and to manage complexity, so operators must invest in what we so called the cloud management technologies and extreme automation. So that includes also orchestration and the zero touch provisioning. I believe this was already also discussed in the Open Run security. And then, of course, one of the biggest enhancements to Open Run is the end of the vendor lockdown age. So in the new Open Run environment, a lot of new vendors will appear to supply hardware and software for each element of the network. So for this reason, it is important that everyone will involve, as well as all providers for this issue will be aware of what's happening or what's the latest update in the Open RAN ecosystem. And of course, one of the main reason or one of the missions of Asia Open Academy is to enhance or build the workforce development, because the Open RAN ecosystem will require a new team profiles. So as we always mention, the lines between the world of telecommunications and the world of IT are now becoming thin. So this implies that the roles of and responsibilities defined so far within the world of mobile networks change with the arrival of Open RAN. So there's a merging between these two worlds, the IT and the telecommunications. So for this reason, one of the challenges that companies face is adapting their teams and knowledge to this new way of deploying networks. Same thing also for universities and campus. If we will deploy Open RAN, so there is a need for expertise of their, for example, current IT team that should have knowledge about Open RAN. It's not anymore just like the typical networking solution and Wi-Fi system solution. Okay, so now this is the Open RAN. And now we'll go to the assessment of and requirement gathering when you try to deploy an Open RAN in your in establishment or a new building. Okay, so what are the different assessment and requirement gathering? So these steps are in a general terms. So meaning each vendor or each operator or each entity can modify the steps that we will be showing here because it depends on the requirement. Okay. So, but this one is assumed that the deployment will be a private network of Open RAN. Okay. So first is to understand the specific needs and the requirements of the school or university. So this one is very important, especially actually in all problems, not only in telecom, but also in other industries. So before you give a specific solution, you need to specifically understand the needs and requirements of your clients or customer. Okay. So in this example, identifying the needs and requirement looks like this. No, it's a simple um, assessment only. So first, you need to identify the user demographics. For example, the number of students, how many are faculty members or administrative staffs. Okay, so that you can have uh, an overview of what will be the serving clients, no, of the system. And then you will also have a usage pattern. So how and when the network will be used and what are the peak times, such as, for example, during lectures or during exams. And then we'll also have the types of applications. So what are the different applications needed in the university or school? Is it video, streaming, online classes, or IoT devices? In the two universities that we have visited so far, so we have seen the applications of drone. So these universities are using drone laboratories or drone arenas. So they are installing outdoor open run system so that they can test the different functionalities and do some research about the different drone applications or unmanned aerial vehicle applications. So if that's the case, if there's a requirement for that kind of use case, it should be included in the assessment and the requirement gathering so that you can identify if you will be deploying an open run, such as an indoor solution or an outdoor solution. Next is site survey and infrastructure assessment. So this is a typical example of a university. Okay. So you can see there are areas that needs to be covered outdoor, and there's a lot of indoor areas that also needs to be covered. So in this reason, we need to have a detailed site survey to assess the existing infrastructure and physical layout of the campus. So this one includes building layout, okay, and then obstruction and interference. So you need to do some signal testing. What is the current status of the network there, and including the existing network. So, for example, if there's already an existing Wi-Fi system in the area, so you just need to identify. And then you can also identify what type of Wi-Fi, if it's Wi-Fi 5, 6, or even 7, if there's an available already. So that this also needed, no. So this is more a generalized approach, no, in doing the site survey infrastructure assessment. After the infrastructure or site survey assessment, you can go for the coverage planning. So once you have the floor plan of the building and you already did the survey, so based from this survey, so you can plan the coverage to ensure that all areas of the campus will have adequate signal strength. So it depends on the type of solution that you will be providing or needed in the requirement. So if it's an outdoor simulation solution, so you need to identify, the cell tower placement. So that, and then you can also provide the outdoor simulation so that you can see what will be the extent of coverage in that target area. And then you can also pinpoint the small cells or Wi-Fi access points if it's an indoor site. So you can see here that there's already a floor plan, and you can see the the plan for the location of different access points, or in the open RAN or small cells, or an omni antenna for if it's a passive distributed antenna system. And of course, the signal propagation analysis. So you will identify where are the weak areas that needs to be covered and what would be the projected coverage, no, or simulated coverage after the implementation of the Open Run. So after you have identified the coverage, you need to check also the dimensioning. So this one is the capacity planning. So capacity planning is also important because coverage is not only sufficient, but capacity is one of the important aspects, because even though the students or the faculties have sufficient coverage, but do if they do not have an enough capacity, so the network will not be serving the needs of your clients or your target people. So the capacity planning ensures that the network can handle the expected load, so without congestion. Okay. So I believe you also experienced this, that for example in LTE covered area, you have a signal, but you cannot even browse a single website. Or if you're browsing the Facebook, cannot load even one photo. So that's a problem of congestion. So you have a coverage but not enough capacity. So in doing this capacity assessment, so I list down only three major component. So you need to check the user density estimation or user density. So that means from the previous assessment, you need to have the survey population and the area analysis. So the survey population is the count of students, faculties, and staffs. For the area analysis, is you can divide the campus into different zones. For example, classroom, dorms, common areas, and estimate the number of users per zone. For example, when we visited the UP Manila, there is an area there where there is a room that handles around 200 students per session. And then those students are connected through to the internet. And then most of them are complaining about the speed of their connection, because it was not I believe it was not dimensioned properly in terms of capacity. Okay, so that's the importance of dividing the area or zoning the campus. And then we have the usage scenarios. So the usage scenarios, you will consider the different scenarios, such as during peak hours, special events, and regular class hours, to understand the variations of user density. For example, in that room of 200 students, how frequent, no, are these students getting class in that area? So you need to put that in this user density estimation. Next is the traffic load calculation. So you will calculate now the traffic load. So for the traffic load calculation, you need to identify the average data usage per user. That is based on the activities that the client or the university has provided you. For example, for streaming videos, browsing, or using the IoT devices. For example, assume that each student will stream videos for 2 hours daily using approximately 1.5 Mbps per stream. So you have that value already. And then concurrent users you will estimate the number of concurrent users in each zone. So remember, we divided the campus in each zone. So for instance, in a large lecture hall, so you might expect around 100 or 200 students using the network simultaneously. And then the total traffic load, so you just multiply the number of concurrent users by the average data. In our example, is 1.5 Mbps. And for example, there are 100 students streaming, so that is equivalent to 150 Mbps of traffic in that zone. So you already know the requirement of the minimum requirement in that zone. Okay. So that's how we do the traffic load calculation. And then last is the bandwidth allocation. So once you already calculated the allocated or the projected traffic, you need now to proceed with the allocation of bandwidth. So first is the application prioritization. So you need to prioritize the bandwidth for critical applications like online classes and administrative functions. So for instance, you can allocate more bandwidth to video conferencing platforms used for virtual classes. So once you set this up, this is set up especially if you have a 5G connection in the in the university or campus. You can have a different slices or different use cases for each applications, and each application will have a corresponding quality of service. Okay. So um the quality of service will implements the policies, no, to ensure high priority traffic that will get the necessary bandwidth. And of course, future proofing. So you can also include that in the bandwidth allocation. So if the current requirement, for example, is 150 Mbps, which is very low, no, you can consider provisioning for 20 Mbps to accommodate future needs. So it is also needed. The data is also needed coming from the client or from the university. How they will project, for example, if their students will increase after certain years. So you need to include that in your calculation so that the system will have enough capacity for capacity augmentation in the future. So this how the capacity, so simplify the capacity planning. And then we have the hardware and technology selection. So you need to select the appropriate hardware and technologies to implement the planned coverage and capacity. So before you proceed with that, of course, one of the important factor, especially here in the Philippines, is to check the available frequencies. In this example, you will see the different allocation of frequencies is very critical, no, to assess. So, for example, in the 5G specifications, there are three major bands where each operator, not only in the Philippines but also worldwide, operating in different bands. There is a band 77, 78, and 79. 77 is 3.3 to 4.2. 78 is 3.3 to 3.8. 4.4 to 5 gigahertz for band 79. So you will see the range of this one in color, in this color. These are the 5G assigned frequencies. Now, if you look at the US, okay, if you look at in the US, how they allocate this frequency, particularly the 3.550 to 3.7, which is in this band, you will see that this band, part of the band, is allocated to the US CBRS band or the Citizens Broadband Radio Service. Meaning, this is a frequency where almost everybody can use. Okay, unless they are not violating some priorities, no. For example, if it's a military application, so the military application will be the priority one on that one. But if the military is not using this frequency, so you can nominate, no, you can be nominated to be used to use this frequency as well. But in the Philippines, you will see that these bands are purely allocated to the mobile network operator. So meaning this is licensed to the operators nationwide. And part of this frequency is also assigned to point-to-point radio communication system. So we don't have this kind of assignment here in the Philippines. That's why it's very critical for a private network to be implemented here if you don't have a frequency. Okay, like the MNO that we currently have. Okay, so that's why it's important, no, for you to check the available frequency. So once you check the available frequency, so you can coordinate with an operator or MNO that you can use their frequency, but you will have a different subscription with them. Okay, probably it's a private network, but the core network will be hosted by the operator, and then you will be just availing some network slice to the operator itself. Okay, it depends on the application of the private network. So once you get the available frequencies, because the hardware will be dependent on the frequencies that you will be choosing. Okay. For example, if it's 3.5, you will be needing a 3.5 radius. So once you finalize the frequencies, that's the only time that you can select the specific equipment needed for your deployment. Okay. And not only the equipment, but also the antennas. Okay. So antennas are frequency specific. So those will be um, um, basing on the available frequencies that you have chosen. And of course, you need software and licenses. Okay. And of course, you will confirm the backhaul infrastructures. Okay. So how much infrastructure or what type of backhaul is needed for you to connect your radio access network going to the core network. And of course, you need to evaluate the vendor support. So it's a common learning from each operator that once they buy a certain equipment with software and licenses, that's not the end of the purchase, no. So there's still a vendor support. There's still a software upgrade. There's still another license activation that is needed on top of your initial purchase. Okay, so that's why you also need to coordinate with your vendor what are the different support or maintenance that you need, or licenses or software upgrades in the future. Now we go to implementation, testing, and optimization. So installation. So this is the time that you will install the equipment, the antennas, okay, on your target areas, and then you will configure it. Okay, so you have the choice. So operator can have the choice or the freedom to do the configuration and integration if they have the capacity or capability. If not, they will be getting an integration support from a third party vendor. Okay. So the integration team will be the one talking to different vendors, because if it's an open run system and then you will use a different software or hardware, there should be a common single point of contact now to to integrate all of these um, components or parts. So once the system is installed, configured, and integrated, so that's time you can check for coverage testing. So you can, this is just a sample of our typical outdoor solution and a typical indoor solution. Okay. So if it's outdoor, you can do the testing outdoors, and then for indoor, you can do testing for indoors if it satisfies your requirement. Okay. And also for capacity testing. Okay, so most of the time we are using a drive test tool or a test equipment to validate the signal and as well as the performance of the site. Okay. And then lastly is monitoring and maintenance. So you need to track the performance and issues of your system once it is already configured. No? So this is just a typical example, one of the fundamental aspects. So you can see here the number of users with respect to the throughput. So this means that in this example, there's a trend that the number of users are continuously increasing. No? Okay, so there's a increasing number of users from the start of the implementation up to the last month of the year. And at the same time, it is affecting the dimension throughput. Okay, so since the number of users are increasing, your system or network's throughput or system's throughput is also decreasing. No, so this one is indicator, no, that you need to have an upgrade in terms of capacity or probably an optimization. Okay, that's why you need to um, track the performance of your network. Okay, and also do regular maintenance. So this includes software update. Okay, so especially vendors release a new version of their software, probably 1.5 or 2 years, every 2 years. So you will benefit also if you have this latest software update. Okay. And there is also a faulty hardware replacement. So you need to have this kind of mechanism or process, internal process on how you will replace or maintain the faulty hardware. So there are also a term called EOS, end of service, and end of marketing. So meaning your current equipment might not be available already because it's already end of service, no? Or end of sales. So meaning when you buy a new equipment, it's already a new version of that equipment. So you need to um, think about that and plan with the existing vendors that you have. And of course, you need to optimize the configuration because probably the initial assessment or assumptions where the concentration of the users are in certain location and then there's a change in the plan or strategy or concentration of users. So you need to optimize these configurations every now and then. So that's why it's very important. It's a continuous monitoring and maintenance. No? And of course, you need to have a user feedback. So you can ask the students, faculty, or admin staff, what is the performance of the network? So when we visited one university, most of them no are complaining about the speed of their connection of their Wi-Fi. Because it was not dimensioned properly, no? So yeah, they have coverage but not enough capacity for that instance. Okay, so those are the different assessments or steps when we try to deploy an open run in a campus or community or campus or university using a private network. Okay.